and ask yourself, why did I get that? And why would I get the other answer? All right? Now, on an examination, you're going to see a similar problem. It's sheer repetition. How long did it take to do? How long? What did it take? First one took how long? Minute and a half. Second one took 2 minutes. Last one took 30 seconds. All right? So basically what, 4 minutes, yes? You're going to do it on an examination. It was easy here because there's no what?
Pressure.
There's no pressure. But when there's 300 of you in the room and it's 85 degrees and you're all freaking out that it's midterm time, adding 2 and 2 is not the easiest thing in the world again. So I highly advise you that you do repetitions of this. That's what the computation sets are for, to learn how to use the tools. The more you do it, the quicker you'll get and the more confident you'll be in the interpretation of what you do. So I highly recommend that you do that. Don't just go, I know how to do this, no problem, and then wait till the examination to try it out. Because I guarantee at that point, you'll blow it, right? The stress will come in and it will just deviate from the ability to answer very simple things. But if not, they're give you points, so why not take them, right? Just do a couple repetitions of it and you'll have it wide. All right, so that's the first tool. So what we're going to basically do here is, I'm going to give you like a tool belt of ecology, right? All the tools that an ecologist would utilize to examine the natural world. This is the first one. Statistics are a big tool that we use. This is a simple stat that we can actually utilize to tell us the difference between sample means and population. All right, so let's just review real quickly. Ecological phenomena comes from a bunch of places. The standard are what? In terms of organism, populations, communities, ecosystems, and ultimately biosphere, right? That evidence is generated from natural systems, manipulative field experiments or mesocosms, microcosms or lab experiments, and mathematical constructs. And then finally, what tools do we use to assign confidence to the experimental results and draw conclusions? Well, we rely on scientific evidence through the process of the scientific method, and we rely on the application of statistics to assign that confidence level. One of the biggest powerful tools that you guys have in terms of analyzing the natural world is the scientific method, right? Scientific endeavor is generated by that simple method. What is it again? I make an observation. From my observation, I ask a question. I create a hypothesis to that question. I then test it, the experimentation. I generate results. From my results, I draw conclusions. And then what do? I do it again, and I replicate it to make sure I get similar results. If I do that enough times, and I always come up with the same results and the same conclusions, I can then generate a what? A theory. That's it. Theory, scientifically, is something based on fact that's been tested rigorously over and over and over again. What is the one thing that we as scientists suck at? What is it? Any idea? I can go talk to a geologist, and we're in great shape. I can talk to a chemist, and we speak our language.
Communication.
Communication with who?
Like a population.
With the general population. That's exactly it. It's the weakest thing that we do as scientists, and we blow it all the time. All right? Here's a prime example. If I say theory, what do I mean? I mean something that's been rigorously tested over and over again, has yet to be disproved. Right? What is this? That's the what of gravity? The theory of gravity. Okay? That's the theory of gravity. Why? Because that's been tested rigorously over and over and has yet to be disproved. As long as these conditions don't change, that same thing is going to happen over and over and over again, all right? However, if I say theory to the general population, how do they interpret it? It's a guess. That's how they interpret it, right? It's a guess, and that's inaccurate. You guys are all fanning yourselves terribly right now. It's hot. It's hot today. What is that? That is weather, right? But it's getting progressively hotter since 1845 is what? Climate change, okay? So what do we call it as scientists? Global what? Warming. Bad idea. Should have called it climate change. Where it's cold, it's hot. Where it's hot, it's cold. Where it rains, it's not raining. Where it's supposed to be raining, it's not. Where it is, vice versa. Weather gets weird with climate change. Overall, global temperatures go up, but weather gets weird. General population. It's the coldest day ever in the middle of July where I am. Scientists are full of crap. Right? Why? Because they're misunderstanding the term because we didn't communicate it properly. So your homework in this class is to learn not just to talk amongst yourselves, but to relay the information to general population, just like your communication major roommate. Okay? All right. So remember that. That's your real mission in this class, is to be able to explain what you've learned. I'm going to teach you guys evolution, right? Basic evolutionary process. There is no larger topic in biology that is more misunderstood in the general population than evolutionary theory, right? Notice the word, theory. Population thinks that it's a what? A guess, and it's not. So we'll talk about it. All right, let's move forward. Let's talk about our map. So you want to investigate the distribution of species and communities. Here's a basic question. Super simple again, typical ecology, right? On the face level, it seems so basic. The why is really tough. Why is it here but not there? That's the question. Why is it here but not there? Okay, so to answer that question, we have to use some logic.